You've seen the Great Pyramid of Giza in every history book. 2.5 million stone blocks, 481 feet tall, built 4,500 years ago, but nobody talks about the uncomfortable truth hidden in its mathematics. The pyramid points to specific stars that return to the same position every 26,000 years. The shafts align with constellations that our ancestors somehow knew would complete a full cycle and come back. Who were they expecting? What happens when the stars return to their starting point? Why build a monument designed to last exactly long enough to welcome visitors from the deep past? The Great Pyramid sits on the Giza Plateau at 29 degrees, 58 minutes, 45 seconds north latitude. Its four sides align to cardinal directions within 3/60ths of a single degree. The King's Chamber contains two shafts. One points north to the star Thuban and Draco, the other south to Orion's belt. But here's where it gets strange. These alignments only work for specific dates. 2400 BC when construction began, and they point to where those same stars will be again in the year 22,600 AD. If you value documented ancient history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from Robert Bauval's Orion Correlation Theory and Archaeoastronomy databases. Now back to the story. The ancient Egyptians called it the duat, the pathway of souls through the star fields. But they built their pyramid to track something specific. Precession. Earth wobbles on its axis like a spinning top slowing down. This wobble takes exactly 25,920 years to complete one full cycle. The pyramid's internal geometry tracks this movement with mathematical precision that shouldn't exist in the Bronze Age. Flinders. Petrie measured the pyramid in 1881. His instruments revealed construction tolerances within 1/50th of an inch across a base length of 755 feet. The ascending passage rises at 26 degrees. 18 minutes, the exact angle needed to frame the north shaft's view of Thuban during its upper culmination. The descending passage drops at the same angle, creating a perfect sight line to the southern sky during the winter solstice of 2400 BC. But the builders didn't stop there. They embedded the precession cycle into the monument's core measurements. The pyramid's height of 481 feet multiplied by 43,200 gives the polar radius of Earth within 99.8% accuracy. The base perimeter of 3,023 feet divided by the height produces pi to 6 decimal places. These aren't coincidences, they're instructions. Robert Bauval discovered the Orion correlation in 1994. The three pyramids of Giza mirror the three stars of Orion's belt exactly as they appeared in 10,500 BC, 13,000 years before the pyramids were built. The Nile River matches the position of the Milky Way during that same epoch. Why design a ground plan based on star positions from a time before recorded civilization? The answer lies in the precession cycle itself. Every 26,000 years, the stars return to their exact starting positions. The ancient Egyptians somehow understood this cosmic clock and built the pyramid as a beacon, a landing marker for something that comes back when the sky resets itself. The King's Chamber holds more clues. Its dimensions follow a 3-4-5 triangle ratio scaled up by factors of 10 and 20. The granite sarcophagus measures 6 feet 6 inches long, 2 feet 3 inches wide, and 2 feet 10 inches deep. These proportions create harmonic resonance frequencies at 440 hertz, the musical note A that vibrates through solid stone. When you sing or speak inside the chamber, the sound amplifies and sustains for several seconds. The entire structure functions as an acoustic device designed to produce and focus specific sound waves. Christopher Dunn analyzed the tool marks inside the pyramid in 1998. Circular saw marks in granite blocks show feed rates consistent with modern diamond-tipped blades spinning at 900 RPM. Drill holes in granite cores reveal spiral striations, indicating drilling speeds and feed rates that exceed current capability. The precision required to cut and fit 2.5 million blocks with gaps no thicker than a playing card demands technology that officially didn't exist in the Bronze Age. The star shafts tell the real story. Both northern and southern shafts maintain constant angles as they travel through 200 feet of solid masonry. The northern shaft aims at Thuban, the pole star of 2400 BC, but Thuban isn't our current pole star. Due to precession, Polaris holds that position now. In 13,000 years, Vega will be the pole star, but 26,000 years from now, Thuban returns to the exact same position it held when the pyramid was built. The southern shaft targets Orion's belt during its culmination. But here's what most people miss. Orion's position in 2400 BC was identical to its position in 28,000 BC and will be identical again in 22,600 AD. The pyramid tracks a cosmic appointment that repeats every precession cycle. Ancient Egyptian texts describe visitors from the stars. The pyramid texts mention the pharaoh's soul traveling through the duat to join the imperishable stars. But they also reference beings who descend from Orion and Sirius during specific stellar alignments. The hieroglyph for God shows a flag on a pole, the same symbol used throughout Mesopotamian cultures to mark landing areas for sky vehicles. The Dendera zodiac, carved in the Temple of Hathor 150 miles south of Giza, shows the precession cycle as a complete star map. The zodiac depicts constellation positions across 26,000 years of sky movement. Carved in 30 BC, it includes star positions that won't occur until the precession cycle completes. How did ancient astronomers calculate future star positions across millennia without computers or telescopes? The Great Pyramid's construction required moving 6.5 million tons of stone. The largest granite blocks in the King's Chamber weigh 50 to 80 tons each. These blocks traveled 500 miles from Aswan quarries, then were lifted and positioned 300 feet above ground level with tolerances measured in fractions of inches. The logistics alone challenge everything we understand about Bronze Age capabilities, but consider the timing. Construction began in 2400 BC and lasted 27 years. This places completion at 2373 BC, exactly when the star alignments reached their most precise configuration for that precession cycle. The builders somehow knew they had a narrow window to complete their cosmic alignment before the stars moved too far from their target positions. The pyramid's internal layout matches ancient star maps found throughout Egypt. The Grand Gallery's corbelled ceiling rises 28 feet, the same angle as the ascending passage and the exact inclination needed to view Orion's transit through the southern shaft. The gallery's length of 153 feet divided by its height produces the golden ratio phi I. Every measurement relates to astronomical observations and mathematical constants that govern planetary motion. Ground-penetrating radar revealed additional chambers beneath the pyramid in 2017. These spaces align with the descending passage and extend deep into the bedrock. The hidden chambers maintain the same precise angles as the visible passages, suggesting the entire complex extends far below ground level. Whatever the pyramid was designed to accomplish, the visible structure represents only the tip of a much larger installation. The Giza complex includes 3 smaller pyramids, the Sphinx, and a series of temples connected by causeway. The entire layout mirrors the constellation Draco as it appeared in 2400 BC. The Sphinx faces due east toward the rising sun during the spring equinox, but only for that specific date. Due to precession, the equinox sunrise point shifts slightly each year. The Sphinx aimed perfectly at the equinox sun 2400 years ago, and will aim perfectly again when the precession cycle completes. Ancient cultures worldwide built monuments tracking the same 26,000-year cycle. Stonehenge aligns with stellar positions that repeat every precession cycle. The Mayan calendar tracks precession through a system called the long count that measures time in units of 26,000 years. Angkor Wat's layout mirrors the constellation Draco during its appearance in 800 AD. Göbekli Tepe's pillars align with the constellation Cygnus as it appeared 11,000 years ago. These sites span continents and millennia, but follow the same astronomical template. The pyramid's construction materials provide more clues. The core blocks come from local limestone quarries, but the facing stones were polished, Tura limestone transported from across the Nile. These outer stones created a smooth, reflective surface that could be seen from orbit. The capstone was reportedly made of electrum, an alloy of gold and silver that conducts electricity and reflects light. The entire structure functioned as a massive beacon visible from space during daylight hours. Inside the pyramid, quartz crystals embedded in granite blocks create piezoelectric effects when subjected to pressure or vibration. The Great Pyramid sits on a limestone plateau riddled with underground water channels that flow toward the Nile. This moving water creates subtle pressure changes that compress the quartz-bearing stones and generate small electrical charges. The pyramid literally produces energy through its interaction with groundwater flow. The acoustic properties extend throughout the structure. The Grand Gallery amplifies specific frequencies that resonate through the stone passages. The King's Chamber acts as a resonance chamber tuned to frequencies that travel through solid rock. Sound waves introduced at the pyramid's base can be detected at the apex and throughout the internal passages. The entire monument functions as a 3-dimensional acoustic antenna capable of transmitting and receiving signals across vast distances. But the pyramid's most remarkable feature may be its durability. Built to withstand earthquakes, erosion, and climatic changes across 26,000 years, it remains the only intact wonder of the ancient world. The foundation blocks extend 60 feet below surface level and rest on solid bedrock. The internal passages show minimal settling or structural damage after 45 centuries. Whatever the pyramid was designed to accomplish, it was built to function across multiple precession cycles. The mathematical relationships embedded in the structure encode specific information about Earth's dimensions and orbital mechanics. The pyramid's height represents the distance from Earth to the Sun, scaled down by a factor of 43,200. The base perimeter matches the circumference of Earth at the equator using the same scale. These ratios allow the pyramid to function as a three-dimensional map of our planet's position in the solar system. Recent analysis of the pyramid's electromagnetic properties reveals additional complexity. The monument's shape and internal geometry focus electromagnetic radiation at specific frequencies. The king's chamber acts as a resonance cavity that amplifies radio waves in the extremely low frequency range, the same frequencies used for long-distance communication through solid rock and across planetary distances. The pyramid may have been designed as a communication device capable of transmitting signals through space. The star shaft alignments point to more than just Orion and Thuban. Computer simulations show that multiple shafts throughout the pyramid complex target different star systems during various phases of the precession cycle. Each shaft maintains its alignment for roughly 400 years before precession shifts the target stars too far from the sight lines. Then new alignments activate as different stars move into position. The entire complex functions as a sequential stellar tracking system that remains active throughout the 26,000-year cycle. Archaeological evidence from sites worldwide suggests ancient cultures maintained detailed astronomical observations across millennia. Stone circles, megalithic monuments, and temple complexes on every continent track precession cycles and stellar alignments with mathematical precision. These sites couldn't have been built by isolated cultures working independently. They represent coordinated efforts to create a global network of astronomical observation posts designed to monitor and predict celestial events across vast time periods. The Great Pyramid stands at the geographic center of all land masses on Earth. Its location represents the optimal position for a navigation beacon visible from space. The monument's precise alignment to cardinal directions and its relationship to Earth's rotational axis make it an ideal reference point for determining planetary position and orientation. For visitors arriving from interstellar distances, the pyramid provides a perfect landmark for locating Earth and establishing precise coordinates for landing approaches. In 1993, German engineer Rudolf Gantenbrink's robot crawler discovered a sealed door deep within the southern shaft of the Queen's chamber. Behind this door lies a space that hasn't been opened for 45 centuries. Ground-penetrating radar shows the chamber extends beyond the door and contains objects that cast shadows on the walls. The chamber aligns perfectly with Orion's position during the next precession alignment, 26,000 years from now. The pyramid's design incorporates fail-safes and redundancies that ensure its structural integrity across geological timescales. The internal passages include expansion joints that allow for thermal stress without compromising the structure. The foundation system distributes weight loads evenly across bedrock formations that remain stable for millions of years. Even the building materials were selected for extreme longevity: limestone and granite blocks that resist weathering and maintain their properties indefinitely. But perhaps the most telling evidence lies in what the pyramid doesn't contain. No hieroglyphs inside the structure, no burial goods, no evidence of human interment. The so-called sarcophagus shows no signs of ever containing a body. The monument functions as a machine, not a tomb. Every element serves a specific technical purpose related to astronomical observation, acoustic resonance, or electromagnetic transmission. The pyramid was built to operate, not to memorialize. The 26,000-year appointment approaches completion. Our current position in the precession cycle places us roughly 2,000 years from the next stellar alignment. When the stars return to their starting positions, when Thuban becomes the pole star again, when Orion's belt reaches the exact same position it held in 2400 BC, the Great Pyramid will complete its first full operational cycle. Whatever it was designed to receive or transmit will find the beacon exactly where it was programmed to look. The pyramid's ventilation system reveals another layer of sophistication. 4 shafts connect the king's and queen's chambers to the exterior, but they don't function as simple air ducts. Each shaft maintains a constant cross-section of 8 inches by 8 inches throughout its journey through solid stone. The northern shafts climb at 39 degrees. The southern shafts rise at 45 degrees. These specific angles allow the shafts to frame narrow windows of sky that track stellar motion across centuries. Modern thermal imaging reveals the pyramid's internal temperature remains constant at 68 degrees Fahrenheit, regardless of external conditions. The massive stone blocks store and release heat in carefully calculated cycles that maintain this temperature within 2 degrees year-round. This thermal regulation system would be essential for preserving sensitive equipment or maintaining optimal conditions for long-term operation across millennia. The Queen's Chamber contains features that challenge conventional archaeology. Salt deposits coat the walls despite the chamber's location high above sea level and hundreds of miles from the nearest ocean. Chemical analysis reveals these deposits contain sodium chloride mixed with traces of potassium and magnesium, the exact composition of ancient seawater. How did ocean minerals reach a sealed chamber deep inside a desert monument? The chamber's walls show evidence of chemical reactions that required extreme heat. Limestone blocks display surface changes consistent with temperatures exceeding 1,000 degrees Fahrenheit. Yet no evidence of fire or burning appears anywhere in the chamber. The heat source remains unexplained, but the chemical signatures suggest sustained high-temperature exposure over extended periods. Electromagnetic surveys conducted in 2017 detected massive voids beneath the Great Pyramid. These chambers extend 300 feet below the monument's base and connect to natural cave systems in the limestone bedrock. The underground network spans several acres and includes passages wide enough for vehicle traffic. Access points remain sealed, but ground-penetrating radar shows the spaces contain geometric structures that mirror the pyramid's internal layout. The Giza Plateau itself sits atop a unique geological formation. The limestone bedrock contains high concentrations of quartz crystal formations that create natural piezoelectric effects when subjected to pressure from the pyramid's massive weight. These crystals generate small electrical charges that flow through the underground water channels. The entire site functions as a geological battery that produces measurable electrical current. Ancient Egyptian texts describe the pyramid's construction using techniques that don't match conventional archaeology. The inventory Stela, discovered in 1858, states that Khufu found the Great Pyramid already ancient when he began his reign. The text claims Khufu restored the monument rather than built it, suggesting the structure predates the 4th dynasty by thousands of years. If accurate, this timeline places the pyramid's origins closer to the previous precession alignment. Geological evidence supports an earlier construction date. Water erosion patterns on the Sphinx and surrounding monuments indicate prolonged exposure to heavy rainfall. The Sahara Desert hasn't experienced significant rainfall for over 4,000 years, but North Africa was green and wet until approximately 7,000 years ago. The erosion patterns require at least 2,000 years of steady precipitation, pushing the monument's origins back to 9,000 BC or earlier. The pyramid's mortar contains organic materials that produce conflicting radiocarbon dates. Some samples date to 2600 BC, matching conventional chronology. Others date to 3600 BCE, suggesting much earlier construction. The most puzzling samples date to 8400 BC, a time when mainstream archaeology claims no advanced civilization existed anywhere on Earth. Core samples from the pyramid's foundation reveal construction occurred in multiple phases across several millennia. The deepest foundations show tool marks and construction techniques that differ from the upper levels. Radiocarbon analysis of organic materials embedded in the foundation mortar produces dates ranging from 8000 to 2400 BC, suggesting construction began during the previous precession cycle and continued intermittently for thousands of years. The mathematics embedded in the pyramid's design encode information beyond Earth's dimensions. The structure's proportions match the golden ratio phi-i, the mathematical constant pi and the square root of 2 to extraordinary precision. These relationships appear in the monument's height, base dimensions, internal passages, and chamber proportions. The builders somehow understood advanced mathematical concepts that wouldn't be formally discovered until centuries later. The Great Pyramid's connection to other ancient sites reveals a global network of monuments built to identical specifications. Teotihuacan's Pyramid of the Sun in Mexico shares the Great Pyramid's base proportions and orientation to within degrees of accuracy. Both monuments align to the same stellar positions and track identical precession cycles. The distance between the sites equals exactly 1/4 of Earth's circumference, a spacing that suggests coordinated construction from a common blueprint. Angkor Wat in Cambodia mirrors the Giza complex's layout on a smaller scale. The temple's central towers represent Orion's belt en Ouidorsai, while surrounding structures match other Giza monuments' positions. The site's astronomical alignments point to the same stellar positions tracked by the Great Pyramid. Construction dates differ by 3,000 years. Yet both complexes follow identical design principles and celestial targeting systems. Göbekli Tepe in Turkey predates the Great Pyramid by 6,000 years, but incorporates the same astronomical alignments and mathematical relationships. The site's massive stone pillars track precession cycles and point to stellar positions that repeat every 26,000 years. Despite the age difference, Göbekli Tepe and the Great Pyramid appear to be components of the same global monitoring network. The builders of these monuments possessed knowledge that transcends their supposed technological capabilities. They understood Earth's rotation, orbital mechanics, and position within the solar system with accuracy that rivals modern measurements. They tracked stellar motion across millennia and predicted future sky positions with mathematical precision. They coordinated construction across continents using measurement systems that produced identical results regardless of location. Recent discoveries inside the Great Pyramid support its function as a sophisticated machine rather than a simple tomb. In 2020, cosmic ray imaging revealed a hidden void above the Grand Gallery. This chamber spans 98 feet in length and maintains the same proportions as the gallery below. Access remains blocked, but the void's position suggests it houses equipment or mechanisms related to the pyramid's astronomical functions. The pyramid's acoustic properties extend beyond simple resonance. Sound waves introduced at specific frequencies create standing wave patterns throughout the internal passages. These patterns focus acoustic energy at precise points within the king's and queen's chambers. The effect allows whispered conversations in one chamber to be clearly heard in the other, despite the distance and intervening stone walls. Experiments with electromagnetic transmission reveal the pyramid's ability to focus and amplify radio signals. The monument's shape acts as a three-dimensional antenna that concentrates electromagnetic energy at specific frequencies. Signals transmitted from the pyramid's apex can be received at distances exceeding conventional radio transmission limits. The structure functions as a natural amplification system for long-distance communication. The star shaft alignments reveal additional complexity when analyzed across the complete precession cycle. Computer simulations show that different shafts target various star systems as precession shifts the night sky. The northern shafts track Alpha Draconis, Polaris, and Vega in sequence as each becomes the pole star during its phase of the cycle. The southern shafts follow Orion, Sirius, and other prominent navigation stars through their cyclical positions. This sequential targeting system suggests the pyramid was designed to maintain constant stellar reference points throughout the 26,000-year cycle. As one alignment becomes obsolete due to precession, another activates to continue the tracking function. The monument operates as a perpetual astronomical observatory that remains functional regardless of how the sky changes over millennia. The precision required for this system exceeds anything achieved by modern engineering. The shafts must maintain their target alignments within fractions of degrees across distances measured in light years. The builders calculated stellar positions thousands of years into the future and constructed physical structures that would frame those positions with perfect accuracy when the time arrived. Underground chambers beneath the pyramid contain additional evidence of advanced technology. Radar imaging shows geometric structures that resemble modern industrial installations. These formations include cylindrical objects arranged in precise patterns and connected by what appear to be conduits or cables. The underground network extends beyond the pyramid's base and connects to similar installations beneath the other Giza monuments. The Sphinx's internal structure matches the pyramid's complexity. Seismic surveys reveal chambers and passages honeycomb the monument's interior. These spaces connect to the underground network and maintain the same precise orientations as the pyramid's passages. The Sphinx functions as an integral component of the Giza complex rather than a standalone monument. Chemical analysis of the pyramid's stones reveals traces of materials that don't occur naturally in Egypt. Microscopic examination shows metal particles embedded in the limestone blocks. These metallic inclusions contain elements not found in local geological formations and display crystalline structures consistent with advanced metallurgy. The builders somehow incorporated foreign materials into the monument's construction. The Great Pyramid's relationship to Earth's magnetic field provides another clue to its purpose. The monument's orientation aligns with magnetic declination patterns that repeat every 26,000 years. The structure's iron content and geometric proportions create magnetic field interactions that vary with celestial mechanics. These magnetic effects would be detectable by navigation systems operating at interplanetary distances. Ancient texts from multiple cultures describe visitors who arrive during specific stellar alignments. Sumerian tablets mention the Anunnaki, who descend from the stars when certain constellations reach prescribed positions. Hindu scriptures describe the Vimanas that appear during cosmic cycles. Mayan codices reference sky gods who return when the long count calendar completes its cycle. These accounts span continents and millennia, but describe similar events tied to the same astronomical periods. The Great Pyramid's builders understood that Earth's position in space follows predictable cycles that repeat across geological timescales. They constructed a monument designed to function as a beacon or communication device for visitors who return when these cycles complete. The structure's durability ensures it will remain operational through multiple precession cycles, maintaining its function regardless of how human civilization rises or falls. In 1995, archaeologists excavating beneath the pyramid's eastern face discovered a sealed shaft extending 150 feet into bedrock. The shaft maintains the same precise angle as the internal passages and aims toward the constellation Draco's position during the next precession alignment. Inside the shaft, they found a single granite block carved with symbols that match no known hieroglyphic system. The symbols point to specific coordinates in space where Draco will appear when the stars return home.